spray booths, fume hoods, ventilation systems. Wherever there's a need for measuring air velocity safely, quickly, and accurately, there's reason enough for using Alnor's UL-listed intrinsically safe Model 9850 thermal anemometer. Because this accurate portable instrument with its battery-operated analog readout can measure airflows from 0 to 2,000 feet per minute in two ranges, 0 to 300 feet per minute and 0 to 2,000 feet per minute, with accuracies of plus or minus 3% of indicated reading, plus or minus 1% of scale, providing a quick response time of 2 seconds after stabilized input, temperature compensated over a range of 68 to 86 degrees Fahrenheit. And the 9850 comes with a 3-inch retractable probe that turns 180 degrees for fast, easy, thorough readings. Whatever the airflow application, if it's critical to human safety or comfort, it should not be without the Model 9850 thermal anemometer from Alnor. How does the thermal anemometer 9850 work? Two thermistors are used, positioned at the end of the probe and exposed to the airstream to be measured. One senses the ambient temperature of the airstream. The other is then heated by the circuit above ambient. As air passes over this heated thermistor, it produces a cooling effect proportional to the airflow velocity, and a change in voltage across the thermistor is created. The thermistors form part of a bridge circuit, which is used in conjunction with an operational amplifier to create a current proportional to the voltage change. This current drives the meter. The range switch changes the amplification factor, allowing air velocity to be displayed on either a low or high reading scale. The switch also has a battery position labeled BAT, where a portion of the battery voltage is substituted for the bridge output, giving an indication of the voltage being provided by the battery. The Model 9850 thermal anemometer is powered by an alkaline 9-volt battery which provides up to 15 hours of power and can be inserted by simply sliding the battery cover on the rear of the instrument near the bottom, away from the case, and clipping the battery to the battery connector. The 9-volt alkaline batteries required to maintain intrinsic safety are the Eveready 522, the Duracell MN1604, or the RadioShack 23-533. Once the battery is in place, slide the cover back to its original position. To use the probe, simply grasp the tip and slide it to the fully extended position. Once it is fully extended, it can be rotated 180 degrees, and the meter can easily read airflows coming from various directions. When in use, the probe must be turned so that the airflow is in the same direction as the arrow on the top of the probe. To turn the unit on, slide the switch at the top of the case to the battery position. Note the position of the needle on the instrument face. It should be in the dark battery zone on the right-hand side of the meter. The further to the right the needle moves, the longer the remaining battery life. If the needle rests in the narrow portion of the battery line, plans for battery replacement should be made. To measure the airflow, slide the switch at the top of the instrument to the high position and place the instrument in the airflow. Check the velocity reading on the meter. If the velocity is below 250 feet per minute, move the switch on the top of the instrument to the low position for better resolution. The operational temperature range of 32 to 122 degrees Fahrenheit should not be exceeded. Face velocities of laboratory fume hoods are established based upon the toxicity or hazard of the materials used. The face velocities can range from 50 to 150 feet per minute, depending on the fume hood class category. The face velocity shall be determined by averaging readings taken at the fume hood face. It is good practice to divide the fume hood face on a grid made up of sections of equal areas approximately 1 square foot and taking a reading at the center of each section. The measuring procedures for spray booths are very similar to the fume hood procedures. The 9850 is capable of reading air velocities at grills, louvers, and duct openings. The recommended method for taking a reading is to divide the opening or grill equally in at least 8 square sections. Readings should be taken at the center of each section, approximately 4 inches away from the opening or grill. These readings are used to determine the average air velocity. After measurements have been completed, slide the switch to the off position. Then, while holding the unit so that the meter is toward the user, align the arrow on the top of the probe so that it points toward the user before pressing the probe back into the case for storage. In the unlikely event you should experience any difficulty with the operation of the 9850, the following performance check could be beneficial. Always start by verifying that the meter reads 0 both mechanically and electrically with the probe retracted into the case. Also check on the battery voltage by reading the meter when the unit is switched to the battery position. When using, if the needle is hitting against either barrier post or is moving erratically back and forth, turn off the instrument and check for breakage of the sensors in the probe. The problem may be caused by a short across either sensor or a broken lead. If the probe arrow is pointed in the wrong direction of the flow, the reading shown by the instrument may not be accurate. When the probe is retracted and the instrument is on, if the needle is not reading 0, check the sensing area for foreign particles. These particles may cause false readings. Since the Model 9850 thermo anemometer is manufactured with solid-state components, little maintenance is required, other than periodic inspections to assure that the unit and probe are clean and not damaged. To clean the meter window, use a liquid eyeglass cleaner. Do not use abrasives or solvents. The case can be cleaned with a mild soap, such as dishwashing detergent, and a water solution on a damp cloth. Do not use abrasives or solvents. Also, do not immerse the instrument or allow liquids to enter the case. Dry thoroughly after each cleaning. It is also important to periodically check the sensing area of the probe to assure that sensors are free of foreign particles. If cleaning is required, use denatured or isopropyl alcohol. Extreme care should also be used to avoid damaging the sensors. Allow the probe to dry completely before using. Always keep the probe in its retracted position between uses. The battery should also be examined at least every 2 months for signs of corrosion. Remove it if there are any signs of corrosion or moisture. Clean the battery connectors and any other affected parts with a clean cloth moistened with water only. Allow parts to dry thoroughly and install a fresh battery such as the ones previously listed. If the instrument is not to be used for more than 2 months, remove the battery and store in a separate container. Environmental conditions such as temperature, pressure, humidity, and air turbulence can produce different effects on the measured results for different instrument types. These differences must be considered when comparisons are made. Do not attempt to adjust any of the calibration potentiometers unless access to a properly calibrated wind tunnel test facility is available. Any attempt at recalibrating voids all factory calibration of the instrument. If calibration must be performed outside the factory, this procedure should be performed in standard room conditions of 77 plus or minus 2 degrees Fahrenheit, 25 plus or minus 1 degree Celsius. Keep in mind that a change in any one adjustment requires calibration of the zero adjustment, high range span adjustment, and low range span adjustment. The 9850 is calibrated by first setting the zero reading mechanically and electrically, and then setting the low range span and high range span. The mechanical zero adjustment consists of turning the instrument to the off position, laying the instrument on a flat surface, and viewing it directly from above. Using a screwdriver, the screw in front of the unit should be turned so that the meter needle is lined up with the zero division. For the electrical zero adjustment, first remove the cover plate. Then make sure a fresh battery is installed and turn the instrument to the low position. Be sure that the probe has been retracted into the case to prevent any airflow, and turn the zero adjustment screw on the left-hand side of the unit until the meter needle lines up with the zero division. To make the low span adjustment, set the instrument in the wind tunnel with the probe positioned so that the airflow is in the direction of the arrow on the probe. Turn the unit to the low position. Set the wind tunnel to 300 feet per minute and turn the low span adjustment screw labeled L span on the left-hand side of the instrument until the meter needle lines up with the 300 feet per minute division. To make the high span adjustment, set the instrument in the wind tunnel with the probe positioned so that the airflow is in the direction of the arrow on the probe. Set the instrument to the high position. Then set the wind tunnel to 2,000 feet per minute and turn the high span adjustment screw, labeled H span on the left-hand side of the instrument, until the meter needle lines up with the 2,000 feet per minute division. As a final check and adjustment, be sure that the probe has been retracted into the case to prevent any airflow from passing the sensors, and check so that the meter reads 0 when the switch is set to either the low or high position. If it does not, repeat the 0 and span adjustments as required until all 3 meter readings are correct without additional movement of the screws. Then replace cover. To verify calibration, you should check the meter against 2 additional velocities on each scale. In case of a broken probe, open the instrument by unscrewing the 4 screws on the back cover. Following this, disconnect the 4 wires from the probe and remove the probe, replacing it with a new probe. When connecting the probe wires, make sure to match the wire colors to the corresponding color labels on the board. Calibration of instrument is required after replacement of probe. In case of a broken meter, again open the instrument, unscrewing the 2 screws shown on the back of the circuit board and replacing the old meter with a new one. Air measurement is safer, easier, and more accurate thanks to the Model 9850 thermal anemometer from Alnor.